Thank you. Thanks, first of all, Laura, for a great presentation and a great topic. I just wanted to, you said that all these problems that you generate in the exams are different. I just wanted to ask, maybe you said during the talk and I didn't realize, it's only the formulas that are totally different or also the text? I mean, do you require the same things?
It's only the formulas.
The formulas,
So, yeah.
I mean,
So,
it's great, but I just, you mentioned at some point that sometimes you ask whether something is sound or not, and sometimes you say prove that it's sound. So I thought maybe it varied a bit also in this kind of sentences.
Yeah, so the text is generic, but I see the point. So that's actually our challenge because of these online exams, and we had to come up with these unique exam problems, we cannot be too creative either, right? So therefore, like, for instance, if I give an abstract theory and ask two abstract theories and ask the students if the combination is finitely stable, this I cannot generate automatically. So I can only at least so far, we could only automate ourselves up to particular syntactic measures. And whenever some more semantics would go into, I mean, at least we couldn't come up with a solution. So we tried to make the exercises hard on them. And then, because it's still fine, it was already before hard. But the online exam is more like making sure that they master the material. But it can be, for instance, that some of the formulas, so for instance, the task is so that prove that it is sound, or is it sound, let's say like this, and some inference will be sound and some inference will not be sound. So the task could be not, so in principle it's the same task, but the result can be different. And it's actually happened that it can be different.
Awesome. Thanks.
We have another question from Luca. Luca, you can ask.
Thank you very much. Thank you, Laura, first of all, for the fantastic talk and very inspiring. My question is on the grading of the exams. So you automatically generate different exams, but if you ask me, I would really love automated grading.
Yes,
do you have it?
Me too. Let's put it this way. So that's the challenge, because you see, like, even with 45 different exam sheets, you have 45 different solutions. We did some things so we don't have automatic grading. I don't even know how to implement that, because a human proof would be very, as also Jeremy mentioned, that a human proof is actually very different than a computer produced proof. Can be actually very different, right? So sometimes, for instance, a computer proof would, whatever proof comes first, we are fine. Same with a human, but probably the human tries to go for simplicity. The computer may not, or the other way around. So we don't have a pattern for that. But we did, so we try to restrict the possible choices of for instance, for a ground superposition problems, we made it so the restrictions that the proof search under the particular ordering, it's almost deterministic. So to some extent, the students there is maybe one or two choices at most, so it means two different solutions. And what we did now in Vampire for that, we extended Vampire with user-provided support. So in the sense that you can specify Vampire or the prover what ordering to be used. So to kind of really mimic the deterministic process that a student can do. But it doesn't mean that the students, what they do is always correct. So Vampire would try to make it correct, but yeah.
So the reason why I'm asking, if I can follow this up, so I've been using the Automata Tutor for a number of years, developed originally by Rajiv Alur and Loris Tantoni and many others. And now I think it's moved to the Technical University in Munich, at least the development of the tool. And what they do is they do automated grading, and they also do automated feedback. And one of this automated grading is based, as far as I recall, on computing some notion of similarity measure between the solution provided, the model solution provided by the instructor, which is stored by the tool, or it could be automatically generated in your case, and what is produced by the student. And then there is some kind of combination of 2 or 3 different measures that gives the final grade. So of course, this is a research topic, actually, Is there a, so I'm just mentioning it here because it could lead to further research and further papers from your side. So is there any notion of similarity measure between solutions that one can devise that can be used to automate the process? But I just throw it out there.
Yeah. I think it's a fascinating question. I wish we would have an. I don't think I have an answer. So it's really hard to say what. Definitely in terms of proofs, which are sequences of number of steps. What is the similarity there? Because every step can be different. I mean, to the invariant generation part, one similarity would be the invariance. So it really connects again to program equivalence. You know, these two programs are equivalent because they have the same invariant, but it's still too vague for correcting solutions. Yeah, but I think it's great. Yeah. Thank you as well.
Thank you. Are there any further questions? Jean-Frede?
Hi, thank you, Laura. A very, very nice talk. So if I may, I have two questions. So the first one has to do with the point on fairness in the exam generation. And I think it's not easy to define these similarity measures, I guess. So my understanding is that you use these syntactic measures, right? So essentially, syntactically, the problems have the same size. And my question is it possible to generate similar questions under this model, but in fact, they're not really similar? So one is more difficult than the other. And if it is, I mean, how could we maybe solve it?
It is. So if you start doing it in the wild, you can get very different solutions. And as I said, the more you allow, the more probability, more solutions you get. So for instance, with our restricted model for a SAT solving problem, we generate over 2 million formulas. So we were making jokes that we will be quite happy for the next years of SAT solving, exercise in SAT solving, right? So how many students can take that? But that's exactly also posteriori, right? So you can make, so if it's completely blind, then you can come up with very simplest, so it's a random problem generation. So you might come up with a structure that uses many connectives, but pretty much uses only one logical variable or one propositional variable. Now this is something that you don't want. So you do a bit of we also do a bit of posterior filtering. But it's still not enough. So it also can be that the logical connectives that we use are too easy. I mean, they don't reflect all the difficulties in the reasoning part. So, I mean, we do, the nice thing is that for us, with only 3 variables, we came up with a large number of problems. So kind of posterior filtering was relatively easy. Well, I don't know if it's fair, but we made sure that, just by the syntactic measures and the number of connectives and the program variables or the logical variables, sorry, they were fine to be similar. But you can come up with from very easy to very hard problems, or hard in a sense, very, very big proofs.
Okay, so I suppose there were no students complaining then, otherwise.
Not yet, yeah.
Right. The other question I have has to do with the first problem. So generating programs from invariants. So something that was not clear to me, you said at some point that you choose pre and post conditions for which the invariant can really prove correctness of the program. But is the choice of pre and post automatic as well?
No, unfortunately not. No.
Okay, so you have to do that task manually.
So that's not that great, exactly. So that's not that great as for automated deduction. So yeah, we use some templates of pre and post condition. Some are easy templates, but if you really want to come up with partial correctness proofs for inductive reasoning, it's used, and the post condition has to make use of the inductive invariant. Otherwise, true or false as an inductive invariant would also work. So yeah, so that's the fine tuning, which is still manual, and it's quite tedious.
Okay, well, thank you very much.
Thank you, sir.
We have a question from Catherine as well.
Yes, thank you, Laura, for your talk. I would like to know if you could use benchmarks for theorem provers?
Yeah, you can actually. We did it. I mean, we didn't submit anything to start solving community because for random start generation, we could actually solve. But yeah, you can generate SMT benchmarks, and we did so. So we generated quite many problems. It's unclear whether they are hard or not hard for the solvers, but we have you can use this framework, and we did it also for especially when our recent work is on induction. So we put one additional property on the formula, and we generate inductive properties by varying the structural induction template and generate hard problems for the solvers. Sometimes these problems which we give to students can be also hard for vampire. So yeah.
Anyone have any more questions? I don't think so. So I'm curious about something. So from the first course that you have to the second, only about 10% of the students go to the second one. Do you have any insights of why that happens, or is it because of the structure of your courses, of the whole degree, not the course that you're doing?
So it's because of the curriculum and how we're organizing it, and logic and computation might not be always popular for software engineering. So they have to do formal methods. And so we have a curriculum which is called software engineering, and we have quite many great students there really working nicely with SMT based approaches, but they might not be interested, right? So they would be interested in other aspects of system or software engineering than logic and computation. And for instance, the logic and computation curriculum only has 20 students, the master students. It's more a research-oriented curriculum, and for those students, automated deduction would be, it's not even mandatory, but it's highly recommended. But we get students from physics taking the course, also from the Faculty of Mathematics. So I think it's just the culture, right? So not everyone likes logic or likes debugging proofs, or even if you use the tools, they might not be interested of now, why should they do that?
Yes, of course. Well, let me just see, is there any more questions from anyone else? Let me just check the chat. No, I don't think we have more questions. Sorry, I have here a strange setup. Right, so thank you very much, Laura. It was a very great talk, very interesting topic. And this was our final talk. Yeah, we have some people clapping. This was our final talk of